Good morning to all of you on this pleasant Monday morning. We are back here with different types of fermentations. In the last lecture, we have seen the alcohol fermentation. This time, we are going to see the acetone butanol fermentation. Now, this is again a very important product associated with fermentation industry, and this product has a wide variety of applications. So, today's lecture we will be discussing about the different types of the fermentation that undergoes with acetone butanol fermentations. The Pasteur first noted this fermentation in the 19th century, in the year 1916. Chaiman Weizmann developed this process using Cornybacterium acetobutalicum, which is till today known as Weizmann process. So this is most important point. It may be asked in the exam as well. What do you mean by Weizmann process? So it is nothing but the acetone butanol fermentation, which was deduced by Chaim Weizmann in the year 1916. Now, before the First World War, the butanol, butadiene, synthetic rubber, so interest was in butanol fermentation. So, before the First World War itself, there were certain products only where the people used to concentrate, and then again, people started developing interest into butanol fermentations. So, later interest was moved to acetone as it was used to produce explosive TNT during the World War. So, and another product of acetone was again considered as it was quite helpful in the World War as well. All after World War II, fermentation was replaced with petroleum-based processes. Majority of plants which less than 200 cubic meter capacities were closed. Some plants are still running with where economic, political, geographical, and climatic factors are favorable. Major products of fermentations are butyric acid, butanol, isopropanol, ethanol, acetone, produced from starch, molasses, sugar, and wood molasses. Now, what sort of strains are being utilized in this microbial production of acetone butanol? Clostridium acetobutalicum. This is one of the most important strain that is been helpful for acetone butanol fermentation. Clostridium butalicum, butanol or isopropanol fermentation. Clostridium butyricum for butyric acid or acetic acid fermentations. Now, biosynthesis. Along with N-butanol, hydrogen and carbon dioxide are also produced. In addition, ethanol can be produced through reduction of acetaldehyde. Butanol at a concentration of less than 0.5% has no influence on the cell wall, whereas higher concentration it causes damage to the phospholipids of cell membrane, and at concentrations above 0.3%, butanol production ceases. Some strain produces autolysis and die. Now, if you see this chart, like from this chart is totally overall for the fermentation itself. Now, if you see with butanol, okay. Now, glycerol there are 3 phosphates and glucose in acetyl coenzyme A. Now, this acetyl coenzyme so undergoes with acetoacetic acid to form acetone, and acetone will go with isopropanol, goes with butyric acid. Correct. Now, this acetyl coenzyme A gets converted to acetoacetyl coenzyme A, butyryl coenzyme A, butyraldehyde, and ultimately butanol. So this type of reactions that we are going to see this right from the fatty acid degradation to productions of butanol and acetone butanol formation. So acetone is also being produced by this particular pathway. See this lactic acid bacteria, pyruvic acid. From pyruvic acid, formic acid can be developed. From formic acid, acetyl coenzyme A. From acetyl coenzyme A, ethanol can be produced. And with the help of this Clostridium species, it produces butanol, which is our desired product in this particular pathway. Few plants are still working in South Africa. Stock culture of Clostridium acetobutalicum are stored at spores in sand for up to 30 years. Although production fermentation is inoculated into lower inoculum, 1:3000, but inoculum is prepared over several stages. Greater resistance to contamination, shorter fermentation time, greater yields, and greater fermentation sugar concentration. So these are certain kind of advantages of the use of Clostridium acetobutalicum for production of the acetone butanol. After sterilization, the fermentation is gassed into CO2 before, and an inoculated fermenter contains cleared CO2. So CO2 plays a very vital role in this particular kind of fermentation. The pH generally has to be 5.5 to 6 up to 36 hours in order to get the fermentation procedures fully completed. See here, you can see here from the potato mash itself through all the processes, ultimately the desired product is will generate. So 36-hour fermentations, 3 phases. During 18 hours, the pH value decreases to 5.2 due to formic acid and butyric acid. See here. During 18 hours, the pH value increases due to conversion of above acid into acetone and butanol. And the last stage group of the solvent production, the pH value remains constant at 5.8. The product can be recovered at pH 5.8. You can see that the product can be easily recovered. See here, from glucose to fructose 6-phosphate, glycerol 3 phosphate, pyruvate. Acetyl coenzyme when goes with acetaldehyde, it will form ethanol. Acetoacetyl coenzyme is been there, acetoacetate, and it will form acetone. This acetoacetyl coenzyme gets converted to 3-hydroxybutyric coenzyme, crotonyl coenzyme, butyryl coenzyme, butanediol, and ultimately butanol. So ultimately from butaldehyde, the butanol formation is there. Correct. This is the acid phase and this is the solvent phase of the reactions. So contamination due to bacteriophages and lactobacilli is a common problem, but absolutely sterile mandatory. This table is there. CO2 produced in the fermentation is recovered and converted into CO2 and dry ice. Acetone, butanol, and ethanol are recovered through continuous distillation and fractionation. So acetone and butanol both are very volatile products, so they need to be distilled and fractioned in order to get them in a very condensed form. The reduced residue left after the distillation are dried and used as animal feed. Correct. Now uses wherein this acetone and butanol has been utilized. So butanol is a valuable solvent for production of lacquers used to prepare finish of automobiles latex enamels. Used as a biofuel, it is similar physical properties to gasoline. Used as additive to plastic to keep them flexible. Used as a solvent in the manufacturing of antibiotics, vitamins, and hormones, and acetone is important in making product. So these are various different applications and uses of acetone butanol fermentations. Correct. So that's all for today. Have a great Monday. Thank you.